Well, good afternoon, everyone. My name is Bridget Maloney, and I am the Managing Director of the University of Waterloo's Corporate Engagement Office called GEDI, and that stands for a Gateway for Enterprises to Discover Innovation here at the University of Waterloo. Before continuing this afternoon, we at the University of Waterloo first want to acknowledge that we live and work on the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee peoples. The University of Waterloo is situated on the Haldimand Tract, the land promised to the Six Nations that includes 6 miles on each side of the Grand River. Our active work toward reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within our Indigenous Initiatives Office. So I'm very pleased you could join us today for this month's 30 Minutes with the GEDI Exchange webinar. It's our second of 3 webinars for this fall. The GEDI Exchange supports the success of startups and scale-ups affiliated with the University of Waterloo, regardless of where the company is located in the world. And it actively promotes collaboration among its members, which are both large and small companies, and with the university. So for today, we'll be focusing on the theme, Microbiomes, Building a Business and Feeding the World. And to talk about that, I'd like to welcome Professor Trevor Charles from Metagenom Bio, who is also a professor here at the University of Waterloo, and Danielle Rose from Ceragen. So they'll introduce themselves and in a moment before addressing that theme. And then at the end, what we'll do is we'll go through audience questions. So the panelist portion is 30 minutes, and then it's followed by an optional 10 minutes of Q&A if you're able to stay with us for that, and I hope you are. So throughout the webinar, please feel free to submit your questions using the Zoom Q&A. It's the Q&A icon in the bottom center of your window. So this event is being recorded and it'll soon be uploaded to GEDI's YouTube channel. So now I'd like to turn it over to our guests to introduce themselves. So let's start with Trevor, Professor Trevor Charles, to introduce himself and Metagenom Bio, and also Danielle to introduce herself and Ceragen. So Trevor.
Hi, everybody, and thanks, Bridget. This is really a great opportunity to tell you about some of the things that we're doing and also, how we translate science to business. So I'm also at the University of Waterloo. I have a research lab. I'm director of Waterloo Center for Microbial Research. And a few years ago, we formed a company called Metagenom Bio with the idea that we could apply microbiome analysis using DNA sequencing to analyzing the microbiome. And I think we're going to talk about what the microbiome is later on. But a lot of people don't associate the microbiome with plants, and especially plants that we eat. All of human society is based on eating food. I think that it's a really interesting context to think about the microbiome in all the ways that it affects the food we eat, from interacting with the plants as they are growing, promoting the growth of plants, reducing stress, which I think Danielle will talk about a little bit, but also all of the microbes that are involved in producing our food and also keeping our food safe. So maybe I'll stop there and pass it on to Danielle.
Thanks, Trevor. I'm really excited to hear more about that. So Danielle, over to you.
Yeah, so my name is Danielle Rose, and I am the CEO of Ceragen, and we are developing probiotics for plants that increase crop yields by improving the plant's response to environmental stress. And so, as Trevor said, what we're looking at is basically the applied use of microbes in agriculture to improve crop yields in a sustainable manner, to help farmers produce more food from the same amount of land, using these beneficial plant growth promoting microbes to help them do that. And my background is actually in microbiology. I did my degree at the University of Guelph, and I actually started my master's degree at the University of Waterloo before putting that on hold to start working on this company full time. So.
Well, that is so very interesting and fantastic, Danielle. Thank you. So why don't we go into the questions? And I have some here for you. So why don't we start by exploring the term microbiome? So these days I'm hearing more about it in terms of, human gut health. Is that what's meant by microbiome? So Trevor, maybe I'll direct that to you first, please.
Sure. People often associate the microbiome with human health, which is natural because we're humans and we're concerned with staying healthy and free from disease. But if you look at the world around you, it's full of microbes. Everywhere you look, every place that you could explore on Earth, there's microbes, and they're doing things. They're sustaining life. They are the first life on Earth that was here for billions of years before any plants or animals were here. So it's not surprising then that plants have their own microbiome. So if you look at the roots of the plants, those roots are actively exuding food for the microbes. So a lot of the photosynthesis doesn't go into growing the plants, but it actually goes into producing food, which feeds the microbes that are on the roots. So those microbes must be doing something good for the plants. And so really what we as scientists want to do is to figure out what they're doing that's good, also figure out which ones are harmful and are going to cause disease and destroy crops, and then to use all of those microbial interactions in order to keep the plants healthy, keep them thriving, and keep them producing food for us.
Incredible. Thank you. I learned something new just there. So thanks, Trevor. Danielle, is there anything you wanted to add to that before I?
No, not specifically. That sums up plant microbiome pretty good.
Okay, awesome. Thank you. That's great. So now I know that both of your companies are connected to research that you, Professor Trevor Charles, have done at UWaterloo. But they seem headed in somewhat different directions. So what's the common thread there? And maybe Danielle, I'll start with you.
Yeah, absolutely. So as Trevor, started talking about the plant microbiome, that's definitely the common thread between both of our companies, is looking at the plant microbiome and how we can use that to basically help increase food production. So the way our company is looking at it is helping give farmers tools that they can use to improve their microbiome. So these are microbial products they add to their growing systems that are directly improving the microbiome of the plant. Whereas Trevor, I guess you can talk about what you're working on, which is a little bit different.
Sure. Yeah. So what we're working on is different, but related, of course, because it has to do with the microbiome. So we have a new activity called healthy hydroponics, and it's basically what it sounds like. We use, DNA sequencing to provide information about what microbes are present in hydroponic systems. So most people aren't aware that half of the vegetables that are produced in Canada are produced in hydroponic systems. And there's also, various forms of indoor farms. And these are very highly engineered systems. The environment is controlled. We actually call these controlled environment agriculture systems. And so we can control everything from the amount of light, the temperature, the humidity, the nutrients, all of that sort of thing, but we don't control the microbiome. And nobody has really gone in there to take a look at what's actually there. And in early work, we've been able to show that the microbiome in these systems doesn't look like a soil microbiome. It looks more like an aquatic microbiome. And so really what we want to do, and part of this is related to what Danielle is doing at Ceragen, is to be able to now engineer that microbiome once we know what it is, and also to be able to follow it as it changes over time, how that's related to productivity, how it's related to disease, and all of those sorts of things.
Well, thank you. That's very interesting and a perfect segue actually to the next question, which is kind of diving a bit more into each company and what it's doing. So what did Metagenom Bio and Ceragen do in this space that brought the theory and lab work done at the University of Waterloo out into the commercial world to make a difference? Maybe even you could, provide examples to support, your comments that you'll make. And Trevor, I'd invite you to comment first.
Sure. I think this is actually a good opportunity to bring up Bernie Glick, who was a professor at University of Waterloo in biology. He's now retired, but he was really pioneering in this area of plant microbiome, and especially in identifying and discovering new mechanisms that are responsible for the interaction between the bacteria and the plants. So when I arrived at University of Waterloo, I already had a research program, but in a different part of plant microbe interactions. And I started collaborating with Bernie, and it was really, I learned a lot from him. It was a very productive collaboration and very synergistic. And so I think that we owe a lot to his vision.
That's fantastic. So the roots go quite far back, no pun intended. That's amazing. So Danielle, maybe you'd like to comment on that journey from lab and research out into the startup world, commercial world, and how the university played a role in that, and maybe any examples you'd like to add.
Yeah, absolutely. So the transition from the research lab in the university to the research lab in industry, because we still do research at the industry level, it's just a little bit different, is kind of an interesting transition. So when you're looking at academia, a lot of what you're focusing on is very novel research. That's kind of the way that things are geared, especially around the funding sources and everything there. So you're looking at proving out kind of basic proof of concepts, new novel ideas. But where we translate things into the industrial lab is more, how do we do the same thing over and over again, faster, really refining down that process. So it's a lot more high throughput, the scale, getting these things refined down to like that ultimate optimized level. So it's when we transition these kind of technologies, say our development pipeline, for example, it was taking the core fundamentals that were developed in the research lab and translating those out into industry, going like, okay, how do we do this faster? How do we do it on a bigger scale? How do we do it repeatedly over and over again to yield better and better results? So that's kind of what that looks like in that transition. And it's definitely an interesting point of view when you do that transition, because I think that both industry and academia can benefit from each other's kind of philosophies. So like translating more automation and high throughput into the academic lab could even yield better research as well.
That makes a lot of sense, and I guess that's learnings and as you went along that you gleaned and you're putting in place. Fantastic. So actually then related to that previous question, I'll ask, so obviously this all speaks to the AgTech movement that I, and I'm sure many have heard about over the recent years. It's basically the application of science and technology to agriculture. So is that right? Is that correct? And how do you see this whole AgTech movement evolving? And Danielle, maybe I'll start with you.
Yeah, so I think the pressure that we're seeing in the AgTech movement and kind of what's starting all of these startups that are coming out and the real focus that's being put there is we have a growing human population and a set amount of resources. So we need to be able to feed all of those people in a sustainable manner that doesn't negatively impact the planet. And also, given the current pressures that we're experiencing from climate change, especially anywhere around the equator, is starting to feel this more and more every year. It's getting increasingly difficult to produce food in a reliable manner. So we see transitions towards things like controlled environment agriculture, and the surge of sort of agri-tech companies because we need to address this problem. Agriculture is a huge contributor to global climate change. So there's a lot of innovation there that needs to happen to both increase the sustainability of agriculture in general, as well as increase the amount that we can produce to continue feeding the human population. And also looking a little bit more at what we're producing. So things like we're producing lots and lots of staples, but things like vegetables, there's a good portion of the human population that does not have access to enough healthy fruits and vegetables in order to meet a nutritious diet. So that's a big thing that we need to kind of look at is like, how are we going to not only just feed everyone, but how do we feed them in a manner that is healthy and promotes the best well-being of these people?
Very interesting that, ag tech, so the science and technology of agriculture actually is so closely related to social impact, social impact, positive social impact, and also the, our environment and climate change. And it's the whole ecosystem is very connected. So thank you for highlighting that. That was very interesting. Trevor, is there anything you wanted to add to this,
Yeah.
This AgTech movement, and how do you see it evolving and the future of it, and how do you play a role?
Yeah, so I maybe just take a couple of seconds to focus in on controlled environment agriculture, so indoor farms and greenhouses, and how that sort of fits. So, these are very highly efficient systems. They're tech heavy, data heavy. They reduce the land footprint and the water footprint by tens or hundreds of times, right? And these are the types of things that we want to do in order to grow more fields, grow more food, to feed more people with fewer resources. The big challenge is energy. So it does take more energy to grow food in these systems. And that's an important problem that needs to be solved. And I think that where the microbiome comes in here is that the microbiome analysis is all about data, right? So we're building data sets, we're building different types of libraries that we can look back on and see how see trends in the data and how that's related to how our food is grown. So it's continually improving our ability to make predictions within this overall AgTech system.
It's fascinating. Thank you for explaining that. Of course, it makes sense there's a large data play, but you don't immediately think of that when we think of agriculture. So there again is another important facet of this whole conversation. So I'll move to a new question. So for Danielle, so in the case of Ceragen, so you're looking to control the microbiome for the benefit of growers' plants. How does that work, and what outcomes are you seeing in the real world?
Yeah, absolutely. So our company is actually starting in controlled environment, just the same as Trevor at Metagenom. So mainly we're looking there because it's kind of an underserved market. There's not as many products available for controlled environment vegetable growers as there would be for people like in the field growing corn or soybeans. So working with these growers to basically help them increase yields in systems that are highly engineered. So the microbiome is one of the few places that we have left to really start optimizing to continue increasing yields in any significant manner, or is one of the options left. So what we're doing is basically providing these growers with liquid inoculant. So it's like, you can kind of imagine as a bottle of bacteria, kind of like a probiotic you buy at the store. And they apply them to the roots of the plants through their traditional watering system. And the way that these microbes work is through stress reduction, as Trevor mentioned. So basically in plants, there's a small amount of a chemical called ACC, and that's naturally present in the plant tissue. And when the plants experience a stress event, like, a heat wave, which still does affect greenhouses because they can heat, but not cool as well, and things like that. So the plant experiences that stress, that little bit of ACC gets converted to a little bit of ethylene, which is a plant hormone. And that signals the plant to turn on all of the beneficial stress response genes. So the plant activates everything and it survives the stress. But then days or even weeks later, what you get is basically as part of that stress response, there is a whole bunch more ACC produced. And if that's not broken down by symbiotic microbes that are naturally present in healthy soils, then you get this secondary massive spike of ethylene, which causes things like leaf yellowing and leaf loss and even death in extreme circumstances. So if those natural symbiotic microbes aren't there, this plant basically self-destructs. So what we're trying to do is reintroduce these natural symbiotic microbes that help the plants regulate their stress in these environments that are naturally present in healthy soils. But the microbiome in a hydroponic system, as Trevor said, is very different. A lot of soil-borne microbes do not survive in hydroponic systems well. So we have to go and find the ones that specifically will survive to help these growers add them back into their systems.
Interesting. So you mentioned ethylene, and is that the same natural chemical that causes ripening?
Yes, so it is a plant hormone. It's involved with multiple different pathways. The one that we're specifically looking at is the stress ethylene pathway.
Interesting. It's fascinating. Thank you. So is this product, so following on, Danielle, from what you've been talking about, is this product only for commercial growers then, or can consumers get it as well?
Yeah, so this initial product's mostly for commercial growers. We actually do have 3 commercial pilots going on with greenhouse tomato growers in Ontario. But we are looking to develop products for the consumer market. So something that's easier to use in, say, a home garden. So at concentrations, that a home gardener can easily use in a format that's like, sprinkleable into the hole or mixed into the soil. So we are running a Kickstarter right now under our new brand name Microbiota, and that is specifically for home gardeners to do pre-orders there. And I can give you the information to share with anyone if they're interested.
That would be great. That's fantastic that you're targeting both commercial and residential applications. That's really fantastic. Is there anything, I don't know, Trevor, you wanted to add to all of that before I move on to a new question?
Yeah, so I think that being able to control the microbiome so that it's optimal, however we define optimal, is really where we need to get. And there's so much potential there. It's completely untapped at this point. So, I don't want to promise anything that we can't achieve, but, doubling food production in these systems is maybe something that we might be able to achieve, and that would really be incredible.
Well, thank you, and that's actually a really good segue into my next question, which is for you, Trevor. Is in the case of Metagenom Bio, so you're looking to measure what's in the microbiome in general. Is that right?
Exactly. Yes.
Yes. So during our prep meeting, you had talked about testing services that your company offers to ensure, crop health and food safety. So how does that work in the microbiome context?
Yep. So in practical terms, what we do if a grower signs up with us, then we have an extensive consultation, make sure that we know exactly what their needs are. And during COVID, we actually had to develop a kit that we could send them, a sampling kit, because we couldn't go onto the farms. So we send this kit that includes a syringe and filter. And so we instruct them to, take the sample, filter it, and then send the material back to us after it's been filtered. And, a typical service would be routine monitoring, on a biweekly or monthly basis that would provide information to the farmer about the crop pathogens that are present and at what levels, the food safety organisms that might be there, the different types of plant viruses even, but probably more importantly, but maybe not so apparent to the farmer, is all of the other extensive data that's collected about the microbiome in their farm that goes back into the database and can be tracked as we develop profiles that change over time.
Thank you. That's a fantastic to hear how you had to evolve as a company and start providing this service. So Danielle, something you said earlier prompted me to think of a question for you. So, we talked about AgTech evolving, and it prompted me to think, what are the biggest challenges you see about innovating in the AgTech space and working with the existing agricultural stakeholders and companies, maybe even in terms of adopting what you're offering?
Yeah, so time is always the biggest issue in agriculture. So for multiple reasons. One, growers are very busy people. So that's always an issue. When you're working in the ag tech space, getting growers on the phone, getting in contact with people, that's not a trivial exercise in comparison to certain other industries. And then time in general, just for how long sales cycles and things last in the agricultural space, especially talking from an investment point of view, where if you compare the ag tech company to say a software company, when your sale cycle is 12 to 18 months, it's in comparison to 2 weeks, you start to run into some issues where like certain investors won't understand kind of those timelines and things like that. So I'd say that the sheer time it takes for plants to grow is one of the biggest issues that most ag tech companies face.
Right. So really a unique industry, and almost requires perhaps investors either with knowledge of the industry sector or patient investors.
Yes.
Yeah. Oh, that's
Yeah.
fantastic. So it also, quick question, is there a significant cost to adopt the product?
So for our product, there is a paid pilot. We do discounted pilots for the first year, and usually growers are testing them on a portion of their farm, so not the entire farm, before they onboard to the full season. We really want to make sure that growers are seeing the return on investment in our farms, and we fully believe in our product, which is partly why we do these paid trials. It's to give the growers the same confidence in our product that we have. So it's like, test it out for a year. We'll help you design the trial. We'll help you figure out how to measure the results so that you can validate that this is a good investment for your farm, and then you'll fully onboard the next growing season.
Great
So
it's to adopt customers. That's fantastic.
Yeah, it's really a relationship building process and making sure that they have the same confidence in our products that we do.
Exactly. Fantastic. So last question, which normally I ask in a certain way, but I'll ask a little bit different today, given that you're both running companies that have launched out of the research here out of Professor Trevor Charles's lab. So, normally at this point I ask, why or how did partnering with the university make a difference? But I think in this case, maybe a better question is, what makes the University of Waterloo startup ecosystem unique and a good place to start up and grow a company?
Yeah. So after coming out of the Waterloo ecosystem and interacting with entrepreneurs from all around the world, and I'm actually in New York at the moment, participating in IndieBio, which is a biotech more accelerator program down here in the States, kind of the next level up, you'd think, from an incubator program where you're really trying to get investment and move faster. And it's that next kind of stage after you figured out your initial product and where you're going. So I would say, talking to other people outside of Waterloo, it's become very apparent that Waterloo is very unique, even on the global scale, where that community and that ecosystem that exists both at the University of Waterloo and outside of the University of Waterloo, more at Velocity, which is the incubator program, and just Waterloo in general. It's a very strong tech community where everyone is really helpful and trying to help push you forward. And it's really a more of a barn raising kind of feeling, those ties to agriculture that we've got in the Waterloo region, where we're all working together to kind of try and build this tech community and accomplish great things. And Velocity is an amazing program that we've had the pleasure of being part of. So the access to the laboratory space, the mentorship that we've gotten, top tier mentorship, I'd even say from a global scale, the advice that they have has really helped push our company forward. And we're much better off for it. And just the University of Waterloo in general, the IP policies that UW has are really huge for fostering innovation and fostering commercialization, where I think that a lot of other universities should kind of pay attention to what Waterloo is doing and the beneficial impact it's having on the startup community.
Oh, thanks, for highlighting the IP policy and the entrepreneurial ecosystem and the incubator Velocity, the University of Waterloo's flagship incubator Velocity. And congratulations on being in the incubator in New York. That's wonderful. And Trevor, any last final comment on the whole ecosystem? Yeah.
So I'll just echo what Danielle said, and also we're launching the Liftoff Black Entrepreneurship Program, and through that process in the last half year or so, interacting with partners within the Waterloo ecosystem, it's really been incredible, the amount of support. And I really understand now what people say about about the Waterloo entrepreneurial ecosystem. Even Conestoga College is a major partner, and they have a great entrepreneurial system. At Laurier, they have the Women's Entrepreneurship System, Women's Entrepreneurship Program, and then also Waterloo Region Small Business Center, which is non-tech and run by the City of Kitchener. And a lot of people don't know that these things are around, but it's really incredible.
Oh, that's fantastic. Congratulations on launching Liftoff. So an incubator for Black entrepreneurs.
Exactly, yes.
That's so wonderful. And we're happy to support that any way we can. So we're at the bottom of the half hour, and so we'll transition into audience questions. And I just want to thank you so much, Trevor, Professor Trevor Charles, and Danielle Rose, for your thoughts. And I hopefully the audience learned as much as I did about microbiomes and how that transitions into building a business and feeding the world. It was very interesting. So now at the 30-minute mark, we're hoping the audience can stay for the optional 10 minutes of Q&A. But for anyone who needs to drop off, I want to say thank you for joining us. And if you do want to exchange some thoughts with Metagenom Bio or Ceragen, please let me know. Your contact info won't be shared outside the university, and we only make introductions at your request. So please feel free to reach out to me, Bridget Maloney, at my email address on the GEDI homepage where you registered for the event. And our next webinar, I'm pleased to say, is on, and last one for the fall before the Christmas break, is on November 16th. And we're going to be discussing reimagining reusing and reducing before recycling. So with two GEDI Exchange companies, GEDIx A and Friendlier. So you'll receive a link to register for that webinar after today's session ends. And please do follow GEDI on LinkedIn and Twitter, or sign up for the GEDI monthly newsletter, because you'll be informed of all of these events and all the news that we have to share. So for those able to stay on for a few more minutes, we'll now begin the optional Q&A. And I'm happy to start that, and want to thank those in the audience who've submitted questions via the registration system in advance or during this webinar. I've been provided with a selection of questions to ask Trevor and Danielle. So, and you're both welcome to contribute to the discussion of the questions, of course, but we'll try and keep them somewhat short, just because we only have about 8 minutes left already. So here's the first question, and it's for Danielle. So this first question came in through the webinar registration system, and I hope I'm pronouncing this correctly, but how would biochar fit into this effort? The person who submitted it, it's anonymous at my end, but personally, I wasn't familiar with the term biochar and looked up before this webinar. Biochar is the solid material obtained from the thermochemical conversion of biomass in an oxygen-limited environment. So biochar can be used as a soil amendment. So for your comment, Danielle.
Yeah, so biochar is not something that we really look into or deal with at the moment. Maybe Trevor might have some more comments around this. As I said, we're mainly working in the hydroponic space right now, where biochar is not really something that gets used. It might under certain circumstances, but not something that's commonly used in these sort of growing systems. These, you can kind of imagine them more as on a trough, you'll have a bag with grow media, usually something like rock wool or coco coir or peat. And then the plants are kind of put on top, and then the roots grow into that slab. So that's kind of the main growing media that they're seeing in these hydroponic grow space, less than say biochar in a soil.
Interesting. Okay, thank you. So lots of questions coming in. The next one is for you, Danielle, and then Trevor, there's one that I'll direct to you. So the next question, Danielle, is someone asks, has research analyzed the relationship between other aquatic life, fish, algae, insects, etc., and the impact, if any, on the microbiome environment?
Yeah, so as far as the impact on the plant microbiome, anything that is present in the ecosystem will have an impact. So as far as like that can be like, you'll see different microbiomes in a field. If, you know, there's corn planted on this side of the field and corn planted on that side of the field, and there's different growing environments in the soil on this side versus that side. So yeah, definitely having other organisms in a growing environment will have an impact. And Trevor, you can probably chime in a little bit more on that as well.
Yeah, I guess what I would add is that in aquaculture, there is something called biofloc, where you actually feed the microbiome and the fish eat the microbes that grow up. So, you know, they provide a lot of nitrogen, so you add a lot of carbon and together you get a lot of microbial growth, and it all sort of comes together in a mass of biomass, and the fish eat that. So that's sort of an interesting microbial community analysis associated with growing food.
Well, thank you. So next question, Trevor, for you. Given the future of sustainable agriculture requires a lot more technology than many of us may have realized, how does that align with many people wanting organic and non-GMO produce? So maybe you could start by explaining the difference between modifying the microbiome versus GMO versus genetic engineering.
Yeah, so I could talk about this all day, but you know, a few comments that I'll make. It's sort of really interesting if we talk about the really highly engineered controlled environment systems, where, you know, you're applying tech to everything, and then the marketing people in the food companies will say that, you know, what comes out of it is non-GMO. Which, you know, they're applying tech to everything except for to the seeds. Although there is a lot of tech applied to the seeds, but people just don't realize exactly what it is. So the thing about organic that is sort of interesting is, you know, organic, for organic, you can't apply what is GMO. So it's actually an engineered microbe. Or an engineered plant. But the thing that is probably has more of an impact is the fact that you can't apply synthetic nitrogen fertilizer or any type of synthetic fertilizer. And the thing that actually makes the biggest impact to production of food is the application of synthetic fertilizer that is produced from natural gas. So in organic systems, that's a perfect opportunity to use microbes to replace that synthetically produced fertilizer with microbial processes, because we know that microbes can fix nitrogen from the air. The air is 80% nitrogen. So it converts that nitrogen in the air to ammonia, and at the same time, the plant feeds the microbe so that they can carry out that reaction. And so that's sort of an area of organic agriculture that surprisingly has not really taken off yet, but I think it's due for some activity in that area.
Interesting. Thank you very much. So I think we have time for one more question before in the next 2 minutes. So Danielle, last one is for you. So are high-tech agricultural tools and methods able to be adapted to the wide diversity of ecosystems, plant hardiness zones, and even cultural practices across Canada or even the world? So for example, how could we use AgTech to increase food security in northern or remote climates?
Yeah, absolutely. So controlled environment is a great example of how you can increase food security in a northern environment. So as Trevor said, the energy does become a limiting factor. So how do you heat and these sort of greenhouse systems? But having that controlled environment where you can do things like put a shipping container vertical farm up in a northern community and have it producing leafy greens all year round instead of trying to ship them in, which requires a fair amount of energy on its own, does offer some really interesting like opportunities for increasing food security. And as far as like globally around the world, that's an interesting problem to solve, but it's definitely one that we can solve with the right technologies, where yeah, we won't necessarily be able to translate the exact same system from, say, something that we're using on large commercial farms out west to smaller, like couple acre farms, say in like Vietnam, where they're like using more traditional techniques. It just might make no sense in that ecosystem, but that doesn't mean that we can't create the equivalent version or an adapted version of those sort of technologies that suits those cultural practices, suits those growing environments. So it's a lot less about trying to take the same technology and replicate it everywhere, and more adapting to the environments, which is kind of like biology does.
Right. Well, I wish we could continue on longer, but unfortunately we're at time. So I want to thank the audience very much for joining us for this Q&A, and a bigger thank you to our guests, Professor Trevor Charles from Metagenom Bio and Danielle Rose from Ceragen. So your insights and expertise are very much appreciated. Thank you very much. So if anyone in the audience, as I said earlier, wants to exchange some thoughts with either of these companies, please let me know. We won't share your contact information widely. We'll just make introductions only at your request. And if you have any further questions or heard something today that intrigued you and you want to explore further with these companies, or you want to learn more about GEDI or the GEDI Exchange, I invite you to reach out to me, Bridget Maloney. You can find my email on the GEDI homepage. So our next webinar is on November 16th, as I mentioned earlier, and we'll be discussing reimagining, reusing, and reducing before recycling. So with two GEDI Exchange companies who are T-Tech and Friendlier. You'll receive a link to register for that webinar after today's session ends. So this will also be shared on GEDI's LinkedIn and Twitter. So please sign up for those GEDI social media feeds and our newsletter and monthly newsletter, and you'll have all the latest news and events. So we look forward to seeing you then. Thank you very much again, everyone. And this ends our session for today.